Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 4-6 Extra Practice Number 5 solutions on solving exponential and logarithmic equations. There's a puzzle that goes with this, so let's see what that's all about. For this puzzle, we're trying to solve the riddle, what do you call pants worn in a flood? We have to solve each of these equations, rounding to the nearest hundredth if necessary. Sometimes it isn't. Once we solve one of these, we're going to put the letters that go with the answer down in the appropriate blanks below. So if I solve number 1 and I got OU for some reason, I would put that down here in these 1 spots. So you're going to get 2 blanks on every single problem that you solve here. So let's go ahead and see what's going on with those pants. For our opening problem, we're trying to solve e to the x equals 5. This is an exponential equation. So I'm going to use logarithms to solve this. I just have to take the ln of both sides because ln and e cancel out. Otherwise, I would just use a regular log. So we have just x then, if I use ln on e to the x. And then I need the ln of 5 as well because I had to take the ln of both sides. And at this point, I do need to use the calculator to get the decimal. So just plugging in, let's see, I need ln of 5. And that comes out to 1.61. 1.61 goes with ED, so we're going to put that in this spot here. So we have an E and a D in the 1 spots. For this next equation, we have ln of x equals 7. So to solve this, I'm going to raise the base, which is base E, to both sides of this. So that'll just cancel out the ln on the left side, giving me just x, and I'll have e to the 7th on the right side. Now I have to plug that in the calculator. So plugging in e to the 7th gives me 1096.63. And that's right here, easy to spot that. That's IT going in the 2 spot. For number 3, I've got 2 logarithms on the left side. So before I can do anything with bases, I need to combine those into 1 log. Since we're adding the ln's, I'm going to multiply the things inside. So we'll have a 3 being distributed to this x and this negative 1. That will give me ln of 3x minus 3, and then I still have that equals 8 over on the other side. Now that I just have ln over here, I can raise e to both sides. So that gives me just 3x minus 3 on the left side, and we have e to the 8 on the right side. Now I have to solve for x. So I can do that by adding 3 to the other side, and I'm just going to leave e to the 8 the way it is for now. I'll use the calculator at the very end here. So we have e to the 8 plus 3, and then I'll divide that by 3 to get the x by itself. And now I'll just plug that in the calculator. So plug in all that in, and I used alpha y equals to get fancy fraction mode in case you're wondering. This all comes out to 994.65. And that is going to be right here. That's TE going in spot 3. So we have a T and an E. For number 4, we have e to the ln of x equals 12. This is really just testing to see if you understand the relationship between e and ln, which is that they cancel each other out. So this literally just leaves us with x on the left side if we simplify it. And then, well, lo and behold, we've actually just solved the equation, x equals 12. So that's ER then, going in spot 4, so E and R. Now we've got this problem to follow up that last one, which was a 1-step problem. This one's got a few more steps in it. So because we're adding these logs on the left side, I'm going to combine those by multiplying the things inside. So this x is getting distributed to the x plus 2. I'm going to rewrite the left side then as ln of x squared, that's x times x, plus 2x. All that equals ln of 35. Since I have a single ln on each side and that's it, I can raise e to both sides. That'll cancel out my ln's and leave me with just x squared plus 2 on the left side and 35 on the right side. Now this is a quadratic, so I'm going to try to factor it to solve it. First I need to move that 35 over to the left, so subtract 35. And now I'm looking for factors of negative 35 that add up to 2. So we've got 1 and 35, that doesn't work. The only other possibility is 5 and 7. If I have negative 5 and positive 7, that would give me a positive 2 in here. So I'm going to rewrite this then as x minus 5, x plus 7. Setting each of these equal to 0 in solving, we have x equals 5 for that first one, and then negative 7 for the next one. Now, just to double check, because I always have to do this when I solve a log equation, if I plug 5 back in, that's not causing me to take the log of a negative or 0, so that's okay. With negative 7, though, that's going to be ln of negative 7. That's not going to work out very well. That's going to be undefined. So because negative 7 makes the original undefined, it's an extraneous root. I have to cross it off, and the only true answer is 5. So 5 is OU. That's going in spot 5 here, so 5's all around. So we have an O and a U right there. For this problem, there's a few ways to handle it. I'm just going to go straight to the point of getting rid of this E by taking the ln of both sides. So that gives me 1 minus x on the left side, and then I have ln of 4 on the right side. And now it's just solving for x and using the calculator. So let me subtract 1 from both sides, so ln of 4 minus 1. And then to really get x by itself, I'm going to multiply everything by negative 1 or divide by negative 1. So I'll have x equals negative ln of 4 plus 1, or 1 minus ln of 4, however you want to think about it. And now I truly need the calculator. So negative ln of 4 plus 1, or 1 minus ln of 4, either way, gives me negative 3.9. So we have a negative answer here. Let's see, that's going to be RS going in spot 6, so R and an S. For this one, I'm going to try to get it down to a single log on each side so that I can then raise e to both sides. On the left side, first though, I want to pop this 4 in as an exponent on the x, just so I don't have any coefficients out there. Now I can merge these two logs together. Since we're subtracting, we're going to be dividing the things inside. So I can rewrite the left side as ln of x to the 4th over 2 equals ln of 128. Now I can cancel out the logs or raise e to both sides, however you want to think about it. So this is just x to the 4th over 2 equals 128 with no ln's. Next, let me multiply by 2 to get this x to the 4th by itself. So 128 times 2, that's 256. And now to get the 4th power to go away, I need to take the 1/4 power of both sides, or the 4th root. I happen to know that 4 to the 4th is 256. So this is 4, but if you don't believe me, we can check it out on the calculator. So to get the x root on the calculator, I'm going to go to math. This works on a graphing calculator anyway. I'm going to go down to this option 5. Let's see, I don't want answer, I want the 4th root. There we go. And let me do 256. And enter. Yep, it's 4. Now technically, the answer would be plus or minus 4. Because you just took an even root, I could raise negative 4 to the 4th power and also get 256. However, if you were to plug in negative 4 up here, you would be taking the log of a negative, which would make the original undefined. So we actually don't need the negative 4 as an answer, just the positive 4, which actually doesn't make anything undefined. So 4 is OV right there. That's going in spot 7, problem 7. So we have an O and a V right there. And that looks like the word over, but who knows? We need to see what comes before it first. For this problem, we have 5 logs in the problem. I think that's the most I've seen in any one of these problems here. Let's start by distributing this negative just to get that out of the way and get rid of that parentheses. So we have ln of 3 minus ln of x minus ln of 6 equals all that stuff over there. And my strategy at this point, I'm going to get the ln with constants on one side and the ln with x's on the other side. I'm going to try to combine everything into one ln on each side, and then I'm going to drop those ln's like a bad habit. So let me start with ln of 3. That can stay where it is. We'll keep this minus ln of 6 over here as well, because why not? And then to get ln of 8 over here, I have to add it. Now on the other side, I'll keep this ln of x where it is, and I will add this ln of x over there to get it to that other side. All right, now to combine these ln's, Wherever we see subtraction, we're dividing by whatever's inside. Wherever I see addition, it goes in the top of the fraction, or we're multiplying. So on the left side, I've got a 3 and an 8, 3 times 8 in the numerator, and a 6 in the denominator. So 3 times 8 divided by 6 inside one big ln. And we'll simplify that a little more in a minute. Over on the right side, I'm adding the logs, so I'm going to be multiplying the x's together. So ln of x squared. All right, at this point, I'm going to simplify all this stuff on the left. We have 3 times 8 is 24, divided by 6 is 4, so we have ln of 4 equals ln of x squared. And now I can raise e to both sides and get rid of those ln's, so that's just 4 equals x squared. And then if I square root both sides, I get a positive 2 for x, and I would also get a negative 2, but you're going to see if you plug negative 2 in for the original equation, you're going to be taking the ln of a negative number, which would be undefined. So because negative 2 makes the original undefined, we don't list it as a solution for this one. So 2 is the only answer that works. That means we're going with CH right here for spot 8, so C and H. For number 9, I have these two exponential terms on the left side. Since they're the same base, I'm going to combine them into one by adding their exponents together. So this would be e to the x plus 3x, or 4x, equals 4. Next, I'll take the ln of both sides to get rid of this e and pop the x out as a multiplier. So this is just going to be 4x on the left side, and then ln of 4 on the right side. And then to get x, I just divide both sides by 4. So I'll just run ln of 4 divided by 4 on the calculator now. So ln of 4 divided by 4 is 0.35. 0.35 is TR, so that's going in spot 9 right there. For this problem, we actually already have x all by itself. We just need to see what this comes out to. Now, I could do all this on the calculator. There's no reason I couldn't, but I feel like I'd be cheap if I did that, so I'm just going to combine these into one big log, then I'll use the calculator. So we can combine the addition by multiplying the things inside, and the subtraction by dividing by what's inside. So this is ln of 3 times 4 divided by 2. That's 12 over 2, which is just 6, so ln of 6. And I'll plug that in the calculator now. And doing so brings me to 1.79 as my answer for this one. That's ES, and that's going in spot 10 right there. For this one, I have a lot of E's going on around here. So a couple things I'm going to do. I want to get all my E to a constant on the left side, and I'll keep my E with the variable on the right side. So I'm going to multiply both sides by e to the 9th to get rid of this 1 over e to the 9th. This e to the 9th times this e to the 9th gives me e to the 9 plus 9, or 18. And on the right side, I can simplify e to the x to the 3 by multiplying those exponents. So that's really just e to the 3x. Now I can take the ln of both sides, or just cancel out the e's either way. This is going to be 18 equals 3x. And then just dividing by 3, we have x equals 6. So that wasn't actually too bad. 6 is going to be BL, and that is going in spot 11, so BL. For this problem, let me combine my logs on the left side into one big log to start us off. So I'll do that by multiplying the 3 and the 2x together. So this is ln of 6x equals 7. And then if I raise e to both sides to get rid of the ln, I have just 6x on the left and e to the 7th on the right. And then to get x, I just divide by 6. So e to the 7th over 6, let me run that on the calculator. E to the 7th over 6 gives me 182.77. And I see that right down here with BR, so that's going in spot 12, BR. Almost there. So this problem is kind of lacking as a final boss battle. We have an ln of an e, so right away those are going to cancel out, and I can just simplify the left side to 2x. And then just divide both sides by 2, we have x equals 3. That is going to give me WA. So let me put that in the remaining spots here with 13. So WA. Now that I've filled in all the blanks, I'm ready to solve the puzzle. What do you call pants worn in a flood? Those would be breeches over troubled waters. Like a bridge over troubled waters, right? But with pants. There's a song about this, right? Like a bridge over troubled waters. All right, I'll spare you the rest. Till next time, Mr. Sutton signing off.